Welcome back to another video. In this video, we'll be discussing about two substances, two important substances in chemistry, which have distinguishing the different properties. And we will look into how to identify them practically, and also we'll also look into some interesting things about this. So we'll learn about, as I said, what acids are. So the definition of an acid and base, and then the practical identification. So basically, there are a few practical tests that you can perform to identify them. And finally, we will learn about a theory called the Bronsted Lowry theory or the method. So let's start. Okay, so if someone asks what acids are basically chemical compounds which are able to produce hydrogen ions. So basically, when you react acids with water, or when you react them, its main feature is it produces hydrogen ions. All right. So bases are chemical compounds which produce hydroxide ions, the OH minus ions it produces. So those are the two features or the two definitions that you can write when they question you about um, acids and bases as for the definition. And also the important thing is bases, when they are soluble in water, they are normally referred to as alkalis. But the important thing is that most bases are soluble in water, so you can definitely refer to them as alkalis. So if you refer bases as alkalis, there's no problem. Okay, so you will see bases are basically like a synonym for alkali. So no problem. So in certain books you will see them as alkali, certain books you see them as bases. So no worries, they both represent the same thing. Okay, so there are certain few examples that I have given here for acids. So sulfuric acid, nitric acid, hydrochloric acid, ethanoic acid, citric acid, acids. And in terms of bases, so metal carbonates, metal oxides, metal hydrogen carbonates, metal hydroxides are the examples for bases. So anything, any metals in the form of a carbonate, oxide, hydroxide, or hydrogen carbonate will be an example for bases. Okay. Outside, apart from these four categories, you aren't able to get any uh, uh, base, except for ammonium. There are certain bases from ammonium also. Okay, but remember this to be for the time being. Okay. Okay, so then I told you about some practical identification that we can do. So we'll do it as classifications, because they will these tests will classify whether a given substance is an acid or a base. Okay, so there are four basically. There's a pH scale, there's a uniform indicator, litmus test, and these other indicators. These other indicators are normally used when we are doing titrations in chemistry. We normally use these two reagents, which is methyl orange and phenolphthalein. Okay, so let's talk about first of all the pH scale and the universal indicator. The pH scale, this is the pH scale. So pH scale has numbers varying from 1 to 14. So if you want to find the pH of a substance, what you do is you will insert a probe. Okay, there's something called a pH probe, and it will give a meter reading. So that pH, if the pH probe and the pH meter, if it gives a reading between 1 to 6, then they are acids. If it gives a pH of 7, it will be water, which is actually neutral. Okay, so water is an example for a neutral substance. So 7 is neutral, and 8 to 14 are bases. So 1 to 6 are acids, 7 is neutral, 8 to 14 are bases. So 1 to 6 only you will find all those sulfuric acid, citric acid, and all those neutral. Best example is water. While for bases, you will find all those metal carbonates, metal bicarbonates, hydroxides and oxides. Okay, so the pH scale is basically about the numbers. Okay, and the universal indicator will only give you these colors, but it has been simplified more. Like here you can see all these colors, right? So from here it goes from dark red to light red and then orange and all those colors. But we normally say that red is for acids, green is for neutral, and purple is for bases. Okay, because we can't say all these colors, no, we can't say this violet and like this. So we just give a overall description, overall color to identify these acids, neutral substances, and bases. And then we have this litmus paper test, the second practical identification that we can use is the litmus paper test. So litmus paper, there are two colors. So basically litmus paper is a paper which has a substance that changes color depending on the substance it is soaked in. These litmus paper comes in two colors. There are red litmus papers and blue litmus papers. So when we want to test an acid, we use the blue litmus paper. Why do we use the blue litmus paper? Because it will turn the blue litmus paper into red color. Okay, so basically if you put a red litmus paper into an acid, it will darken the red litmus paper. It will become more red, or maybe it will be just soaked. So we don't want that to happen. We want to see a correct color change. So how do we see a correct color change? By adding a blue litmus paper. Okay. Then if you want test for a base, you should add a red litmus paper. Why? Because the red litmus paper will turn blue in color. So if you add a blue litmus paper, it will become more blue. So you want to be very accurate about this. So that's why we use a red litmus paper to see a distinguishing color change. So if you add a neutral substance, uh, if you soak this blue litmus paper or the red litmus paper into a neutral substance, there won't be any color change. So if there is no color change with either of the litmus papers, that means it is a neutral substance. Okay, simple as that. So these diagram will show you correctly. So you can see. So if it's an acid, the blue litmus paper is turned into red. If it's a base, the red litmus paper is turned into blue. And neutral, there is no color change. Right. Now we said about special indicators. These are indicators that are used in titrations, as I said earlier. So one is methyl orange, the other one is phenolphthalein. So methyl orange itself is orange in color. Okay. So when it is added into a acid solution, it will change into red color. If you add it into a base, it will turn into yellow color. Okay, if you add phenolphthalein into an acid solution, it will be colorless. If you add phenolphthalein into a base, it will be purple in color. So you will see a distinguishing purple color. So keep in mind these color changes because they are very important uh, in answering questions. All right. Then we come to this important theory, which is called the Bronsted Lowry theory. So according to this Bronsted Lowry theory, it is said that an acid is a proton donor, or in other words, we can say it's a hydrogen ion donor, H plus ion donor. Base is a proton acceptor, H plus ion acceptor. Okay, so why do we need this? Now we discussed about four practical situations. So yet why do we need these theory? It is needed because certain bases and certain acids cannot be straight away. You can't identify them whether they are bases or they are acids, because there are some substances in certain reactions they act as bases, in certain reactions they act as acids. Okay, so they have both those properties depending on the situation. So because of that, this Bronsted Lowry theory is very, very important. So let's see an example of this. So here we are using water, and we are taking water and a base called ammonia. This ammonia. Okay. So here you can see after this reaction had taken place, you are able to get an ammonium ion. and a hydroxide ion. Okay, so what has happened here is a hydrogen from the acid has been donated to this ammonia, and as a result we are able to get ammonium ion. So that's why you can see there's an H4 plus, and here you don't have a hydrogen been donated, so you get a OH minus. So as a result, now in these reactions we will consider some new terms which we say as conjugate acid and conjugate base. So what they are, basically conjugate acid is a resulting acid as it contains a positive charge. So the positive charge will always be the conjugate acid, whereas the conjugate base is a resulting base, it has a negative charge. So this will be the conjugate base. Okay, remember that. This is very important. Conjugate acid, conjugate base, very important. Another way to distinguish this conjugate base and conjugate acid is counting the number of hydrogens. The resulting products, the one that has the higher number of hydrogens will be the conjugate acid. The one with the lesser number of hydrogen will be the conjugate base. So here also, if you consider that theory, NH4 will have, it has 4 hydrogens, this has only 1 hydrogen. So this one definitely should be the conjugate acid, this one should be the conjugate base. So you can see ammonium ion acts as the conjugate acid, hydroxide ion acts as the conjugate base. Okay, so this is the example for water acting as an acid in a reaction. Let's see the other side of it. Here we are reacting HCl with water. So in this case, water acts as the base. Why? You can see this reaction. This is called hydronium ion. This is called chloride ion. You know this ion very well. Here, what has happened is a hydrogen from the HCl is been donated to this water, and you are able to get this ion. As a result, when this hydrogen goes away, HCl doesn't have a H. It only has this chloride ion. So chloride ion is there. Okay. So in this case also, what will be the conjugate acid? Here it's very easy to find the conjugate acid because there's only one product on the product side which has a hydrogen. So hydrogens here, more hydrogen. So that will be the conjugate acid definitely, and it also has a positive sign. Okay, so all the characteristics of a conjugate acid can be identified here. So this will be the conjugate base. So these terms are really important in this Bronsted Lowry theory. Okay, so Bronsted Lowry theory, what you need to really know is what Bronsted Lowry theory tells about acids, what it tells about bases, what is a conjugate acid, what is a conjugate base, be very clear about it, and why do we need this Bronsted Lowry theory. Those three keep in mind very well. Okay, so with that we come to the end of this video. In this video we discussed about acids and bases. We started with giving some examples of what acids and bases are. And acids are substances that produce hydrogen ions, H plus ions to a solution. Bases are the substances that produce OH minus ions to a solution. All right. And then we discussed about 4 techniques that is used practically to distinguish acids and bases. It was the pH scale, Neusser indicator, litmus paper, and also 2 special indicators that we use, especially in titrations between acids and bases. That you will learn in the next video. Titration you will learn in the next video. So those indicators were methyl orange and phenolphthalein. Remember the color changes in all of those practical indicators because it's very important in answering questions. And then finally we learned about this Bronsted Lowry theory, where we learned about new concepts, new words, new terms like conjugate acid, conjugate base. So be familiar with all of that and you will be good enough to do any questions that will, in answering any questions that will be given to you. So thank you, and I'll meet you in another video.